Good morning, students. Welcome back to the next class on the chapter of friction. I welcome you all to this online class in physics for standard 8 on the chapter of friction. Last class, students, we discussed about friction, its introductory idea. We discussed two important factors on which it depends. I hope you have revised it properly and you had made your own notes. Today, in this class, I would basically discuss the basic types of friction that are given in your textbook. So, three types of friction will be there, which you have to read. One is static friction, then sliding or kinetic friction, and third one is rolling friction. One by one, I shall discuss them. First of all, I would like to discuss about static friction. Friction you have understood, students. Now, static. What does static mean? Static means something which is not moving. That is the technical meaning for the word static. Supposing there is a table or there is a surface, some kind of surface, and on this surface there is an object. This object has some mass, say small m. There can be many examples for this. For example, table resting on a floor, book resting on a table, book resting on the floor of your house, and so on. Any object resting on some particular object. So this is one surface and its base of this object is another surface. Those two surfaces are in contact. If you apply very small amount of force, which I denote by capital F, that is applied force towards the right, and you find that the object does not move and is at rest. So last class I have discussed that if there is a body which is at rest, then net force on the object must be 0. You have applied a force F towards right, that means there must be some force towards left. For example, suppose this is a surface and on this surface I put some object like this. And now I apply with my finger a small force, very gentle force on this particular object towards the right, as indicated in that figure. So if I apply a force, I find first that on applying a very small amount of force, this object does not move. Now it might be difficult for you to perceive this. What you can do, you can repeat this activity with a heavy table in your room. That heavy table with a single finger, if you apply a gentle force, you will find it is not moving. It will not move initially. Then you go on increasing your force. After some time, you will find it starts moving. Suppose it is that table. First, you apply some amount of force, and on applying that force, the body does not move. It remains at rest. If it remains at rest, that means I mean to say there is no relative motion between the two surfaces in contact. This is one surface, this is other surface. There is no relative motion between the surfaces in contact. In this case, I had discussed in the last class, this is possible only if the net force on the object will be 0. Since the object is at rest, so net force must be 0. There is one force towards right, that is capital F. So there must be one force towards left, and that force, you know, that is nothing but the force of friction. That we denote by small f. Small f is what? Small f is frictional force. Since this frictional force operates between these two surfaces when they are at rest at rest relative to one another. That's why this kind of frictional force is called as static friction. There is friction. It has some value, and how much will its value be? Its value will become equal to the applied force. See, both these forces are equal in magnitude and they are acting in opposite direction. So you know, if there is an object, one boy or one person pulls it towards right, one person pulls it towards left with the same force, then this object will remain at rest. It will neither move to the right nor it will move to the left. So F is equal to F. This kind of friction is called as static friction, and hence I will use a subscript ST. ST for static. So let's understand the definition for static friction now. So this is the definition for static friction. Students, if you remember, in the last class I have told that you should now learn to make your own notes. You should use your own words. If you wish, you can write definitions from your textbook. This is just the meaning of that. Languages may vary, and if you wish, you can put in your own words also. When there is no relative motion between a pair of surfaces in contact, somebody can write this also like, if two surfaces in contact are not moving relative to one another. Some person can also write, if one surface is at rest with respect to another surface in contact. So see, there are many terminologies. You choose as per your wish what suits you the best. No relative motion means one object and the other object, or one surface and the other surface which are in contact, they are at rest with respect to one another. So whenever there is no relative motion between a pair of surfaces in contact, then the frictional force acting between them means the two surfaces in contact, is referred to as static friction. And this static friction is equal and opposite to the applied force. If applied force is towards right, frictional force will be towards left. If applied force will be towards left, then frictional force will also become towards right. It will change its direction. And not only it will be in opposite direction, but it also has same magnitude. This is the meaning of static friction. Let's see one important property of static friction. One very important property about static friction is that it is self-adjustable force. Self-adjustable means by itself it can adjust its direction as well as its value. Let us try to understand this. So this is the surface and this is a body on that particular surface. In horizontal direction there is no force. So the applied force is 0. Do you think there is frictional force? Answer will be no. Because if you are thinking there is frictional force, then tell me, students, what is the direction of frictional force in this case? Frictional force direction on this notebook. Is it right, left? Because you know frictional force always tends to oppose the motion. It does not have any tendency to move now. If I apply a force like this, then this body would develop a tendency to move in that direction, that is right direction. Then frictional force will act towards left direction. But if I am not applying any force, that means if the applied force is 0, then frictional force is also 0. So first important point. If capital F, what is capital F? You should write complete statement, applied force. If capital F is 0, then the static friction is also 0. So there is no force, so the object will remain at rest. Now suppose I apply a very small amount of force in that direction, such that the object should not move, like this. So suppose there is a table, that table you are pushing towards right, but with a small force, such that the table does not move. We say this is the direction of applied force towards right, there must be static friction acting towards left, just like this, and they will balance each other. The small f static friction and capital F applied force will be equal in magnitude, opposite in direction. If that condition is satisfied, then the object will remain at rest. So see, static friction was earlier 0, now it developed some value and it is acting towards left. Now I will change my direction of force. Suppose I go to that side and from that side I start pushing this particular object. If I apply force in this direction, then this object will have a tendency to move towards left. Now the frictional force will act towards right, opposite to the direction of applied force. If you reverse the direction of applied force, frictional force will also get reversed. Is it clear, students? That's why it is self-adjustable. It not only adjusts its direction, but it also adjusts its value or magnitude. Suppose I apply 0.1 Newton force, then static friction is also 0.1 Newton. I increase my force to 0.2 Newton, static friction is also 0.2 Newton. So both these forces are equal in magnitude and opposite in direction. That's why the copy remains at, or the object remains at rest. Same thing will be true for the table resting on a floor. But do you think this static friction will go on increasing its value? The answer is no. There is a limit. So what I told, if you go on increasing the value of applied force, the frictional force also increases its value and reaches to a maximum value. So what I told, if applied force is increased, these are very important. If applied force is increased, static friction also increases such that the object remains at rest. The object remains at rest. If I further increase my force, or if I further increase the applied force, static friction also further increases. This continues till static friction reaches its maximum value. Maximum value. This is also called as limiting value. What do I mean with this? I mean to say that there is a limit to which this static friction can increase. As you go on increasing your applied force, this static friction also increases till it reaches some maximum value that we call as limiting value. So this friction, this is called as limiting value of frictional force, which we will denote by F limit. F LIM. LIM for limit. Clear? So what is the meaning of this? This is limiting value of static friction. Static friction cannot increase beyond limiting value. Let us try to understand this. Suppose I take an example for the static friction between the table and the floor. That static friction has a limiting value, F limit, that is suppose 10 Newton. Just I am assuming it, it can be more, it can be less. Let us assume it to have a value of 10 Newton. So suppose the limiting friction or the maximum value of static friction is 10 Newton. Suppose you apply a force of 1 Newton towards a right. Then this static friction will also be how much? 1 Newton. Now you increase your force to 3 Newton suppose. Then this static friction will also increase to 3 Newton. That is the meaning of this statement, static friction is self-adjustable. So this will continue. Suppose you increase to 8 Newton, this also becomes 8 Newton. You increase your force to 10 Newton, this will also increase to 10 Newton. Now after 10 Newton, if you increase the force, this static friction will fail to increase its value because it has a maximum limiting value of frictional force to be how much? 10 Newton. Remember, I have taken 10 Newton as an example, as an illustration. The actual values may be different. Now suppose I apply a force of 11 Newton. 11 Newton. Then do you think static friction will become 11 Newton? No, because I have told limiting value is how much? 10 Newton only. So it will remain 10 Newton. Now what will happen? There is a force of 11 Newton towards right and there is a force of 10 Newton towards left. Which is greater? Right force is greater. So therefore the object will move in the direction of greater force. So the object will start moving in this direction. Now the object will not be at rest. The object will start moving, and when the object starts moving, the friction between this surface and this surface will not be called as static friction, that we will call as sliding friction. So is the concept of static friction clear, students? It is a very important fact. Static friction is self-adjustable. It can change, it can adjust its direction as well as magnitude according to the applied force. But there is a limit to increase its value. That limiting value or maximum value we denote by F limit. If we apply force, so that is a very important point. If applied force is less than limiting value of static friction, then the object remains at rest. But less than or equal to. But if the applied force becomes greater than the limiting friction, then net force is not zero and object starts moving. Object starts sliding, you can write, or moving. And then the friction between the pair of surfaces will be called as kinetic friction or sliding friction. Okay. So all these points, students, you should make in your notes. Just as you had written definition for static friction, likewise you will write the definition for sliding friction also. So the definition for sliding friction can be given like this. Sliding friction is also called as kinetic friction. If in some textbooks, if you find kinetic word, don't be confused. Both sliding or kinetic friction are same. So the frictional force between a pair of surfaces in contact, you should write in contact, which slide relative to one another. If this is one surface, this is another surface, and one of them is sliding with respect to the other, then the friction between them is referred to as sliding friction or kinetic friction. So we have discussed till now static friction and sliding friction. The third type of friction is the rolling friction. Students, you might have observed the example of table which I discussed just now, that you have to move a table by applying some force onto the floor. You will find if the table is heavy, you will have to apply large amount of force to make it slide. But at the bottom of the table, if we put some wheels, if this table be fitted with, or if there be any object and that is fitted with wheels, then this force which you have to apply becomes very less. The kind of friction that operates between a wheel and another planar surface, that is referred to as rolling friction. Clear? So how will you define it? The frictional force between a pair of surfaces when one surface rolls over the other is called as rolling friction. So that goes as the definition for a rolling friction. So we can define rolling friction as this, that whenever a body rolls over another surface, then the friction between the two bodies or the two surfaces is referred to as rolling friction. So about rolling friction, I told the students it is very, very less. So two statements I will give. So this is all about the types of friction. Sliding friction, what is its other name? Kinetic friction. Sliding friction is found, it is found that it is slightly smaller or less than static friction. So sliding friction for a pair of surfaces, for two surfaces. Sliding friction for two surfaces, any pair of surfaces, is slightly less than the static friction between them. And second thing is that rolling friction is very, very less compared to sliding friction. And this reduces our effort to move a body from one place to another place if you fit that body with some wheels. And it's for this reason that the discovery of wheel is considered to be a revolutionary discovery in the history of mankind. Imagine if you are asked to push a car on the road with a condition that its wheels are removed. There are no wheels. Then the force which you have to apply to push this car should be greater than the limiting friction between the car's body and the road. That will be very, very large. But if you fit it with wheels, then the rolling friction between the wheels and the road is quite less. You might have seen sometimes when the engine stops working, persons go out and they push the car. Imagine this car is very heavy. Its mass is quite large. But such a heavy car they are able to push on the road and the car moves forward. Sometimes people do that. One person or two person or three persons, they go to the back of the car. Even buses also, they sometimes, if needed, they push them. So because they are fitted with wheels, those wheels offer very small amount of friction. That's why people manage to push the four-wheelers on the car. What is the reason for that? Reason is this, that the rolling friction is very less compared to sliding friction. Now if these two statements, I combine them together, then I can write rolling friction is very, very less. If it is less, I will write one symbol like this. If it is very less, I will use this symbol. What is the meaning of this? It is very, very small compared to sliding friction. Is it clear, students? And sliding friction is slightly less than what? Can I write static friction? See, you might find this thing in texts, but students, be careful. I have told static friction is self-adjustable. While discussing static friction, I have told you static friction can even be 0. Sliding friction cannot be less than 0. So never write sliding friction is less than static friction. You should write sliding friction is less than maximum value of static friction. Clear? So that maximum value of static friction we call as limiting friction. Here also I should rectify my statement. The sliding friction for two surfaces is slightly less than. Static friction between them is not correct. It is the limiting value of, limiting or maximum value of static friction between them. So you should remember this. Rolling friction is very small compared to sliding friction or kinetic friction, and that kinetic or sliding friction is slightly less than the limiting value of static friction, which we also called as limiting friction. So limiting friction, how do we define? If somebody asks you the definition for limiting friction, let me give that also. Limiting friction definition will be, it is the maximum value of static friction. Is it clear? The maximum value to which static friction can increase, because you know static friction is self-adjustable. It can increase to a certain limit. that maximum value till which static friction can increase is called as limiting friction. Okay students, I'll stop today. So today we discussed basically the three types of friction. Please consult your textbook also and make notes with the help of the lesson that I have delivered today. So we discussed three types of friction, that is static friction. Then we discussed its maximum value, that is limiting friction. Then we discussed about sliding and then rolling friction. We will proceed further in the next class. Till then, take care and read these contents properly. Okay, thank you. See you in the next class.